So let's talk about the square root function. So the square root function, which is f of x equals the square root of x, matches each real number with its principal positive square root. Because we cannot take the square roots of negative numbers, its domain only goes from 0 to infinity, and its range goes from 0 to infinity as well, with 0 included. So it maps 0, the square root of 0 is 0, 1, the square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. So this is what it looks like. It kind of looks like half of the I'm a Little Teapot dance. The cube root function pairs each real number with its cube root, and its domain goes from negative infinity to positive infinity, as does its range. Because remember, I can take the cube root of negative numbers, right? The cube root of negative 8 is negative 2. The cube root of positive 8 is 2. So how am I going to graph radicals? Well, we want to start by finding at least 3 y values. And what you want to do is you want to choose your x values by setting your radicand, that's what's under the radical symbol, equal to perfect squares. So the first perfect squares are 0, 1, 4, 9, right? And you want to use these to solve for your y. So what we're going to do is we're going to choose our x values by setting what's under our radicand equal to 0, equal to these perfect squares. Then what we want to do is state our domain and our range. So we need to list all possible x values and all possible y values. So the first thing I want to do is I want to choose my x values. And I'm going to do that by taking what's under my radicand, which is x minus 3, and setting it equal to perfect squares. So we got x minus 3 is 0, x minus 3 is 4, and x minus 3 is 1. I don't know why I skipped that one. So I'm going to add 3 to both sides. We want to solve for x. So I get x is 3, x is 4, and x is 7. These are the 3 x values I'm going to use. See, I already have them here, 3, 4, 7, because that means my answers will be nice numbers. It means my answers will not be radicals, they'll be easy to graph. So let's take a look at that. So I'm going to now substitute in, let me clear this because that wasn't helpful. I'm going to now substitute in my chosen x values into my function. So I have the square root of 3 minus 3. Well, that gives me the square root of 0, which is 0. So I have when x is 3, 1, 2, 3, y is 0. Next I have when x is 4, so I've got the square root of 4 minus 3. That's the square root of 1, which is 1, right? Kind of see what's happening here with what we set them equal to. So when x is 4, y is 1. And then I have when x is 7, I've got 7 minus 3. That's the square root of 4, which is 2. So when x is 7, kind of out here, y is 2. So this is my function. My domain has been shifted to the right because my function starts when x is 3. So my domain goes from 3 to infinity, and my range goes from 0 to infinity. In order to make our graphing of functions easier, especially radicals, we're going to talk about how we can shift our function around the xy plane. So the first thing I want to talk about is vertical shift. So if I have the graph of a function f of x, and it is equal to f of x plus k, it's going to have the same shape as my original graph, but it's shifted k units along the y-axis. So it's shifted k units vertically. So for example, in red here I have y equals the square root of x. If I was to add some constant, I would shift my graph up c units. If I was to subtract some constant, I would shift my graph down c units. And we've kind of seen this before. Let me show you where. So I'm going to go ahead and switch to a nice bright color that we can see. So here's our lovely XY coordinate plane, and way earlier in the in this course, we learned to graph lines like y equals x. So that's when y equals x. So I got 1, 2, 3, -1, -2, -3, 1. So here's my beautiful coordinate plane. Don't you love it? So I'm going to go ahead and graph in blue y equals x. So that means when x is 0, y is 0, or my y-intercept is 0, my slope is 1, so I go up 1 over 1, 2 and 2, 3 and 3. It's not the perfect line because I don't have a perfect coordinate plane, but this is the line y equals x. What if I asked you to graph the line y equals x minus 3? Well, that graph is shifted down 3. Now my y-intercept, instead of being 0, my y-intercept is -3, but they have the same shape because they have the same slope. I'm going to go ahead and graph this one in orange. Wait, that was a poor color choice. Let's try that again. I'm going to graph this in red. So here I have the line. My y-intercept is -3. My slope is 1. I go up 1 over 1, up 1 over 1, right? These lines are parallel. They never intersect. They look the same, but I shifted my graph down 3. I could also shift my graph up 3. What if I wanted y equals x plus 2? This would be the graph shifted up 2. I've added a constant. I have the same slope, but now my y-intercept is 2. So here's that line, right? This is y equals x plus 2, y equals x, and y equals x minus 3. You didn't know, but when we were graphing those linear functions, we were shifting our graphs up and down the y-axis. So if I want to graph f of x equals the square root of x plus 2, how is that graph going to be shifted? So first, why don't I draw the function f of x equals the square root of x. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. So this is the graph of our function square root of x. Now I want to add 2. That's going to shift my graph up. Let me show you how. So when x is 0, I'm going to have the square root of 0 plus 2, which is 2. When x is 1, I'm going to have the square root of 1 plus 1, which is, plus 2, which is 3. When x is 4, I'm going to have the square root of 4 plus 2, which is going to give us 4. So let's graph our new function in green. So when x is 0, y is 2, 1, 2. When x is 1, y is 3, 3. When x is 4, y is 4. Here's our new function. See, it has the same shape as the square root of x, but it's been shifted up 2. So now I've got the cube root of x minus 3. Let's go ahead and draw real quickly the cube root function. 0. When x is 1, y is 1. When x is -1, y is -1. And I don't have a -8 to be 2. But it's going to kind of look like this function. So -1, 0, 1. So how is my graph shifted? Well, this is going to be shifted down 3. Let me show you how. If I took the cube root of -1 minus 3, that's going to give me -1 minus 3, which is -4. If I have the cube root of 0 minus 3, that's going to give me 0 minus 3, which is a -3. And if I've got the cube root of 1 minus 3, that's going to give me 1 minus 3, which is -2. So let's go ahead and graph those points and take a look at how my graph has shifted. We're going to graph our new function in blue. So I have, when x is -1, y is -4. 1. I have when x is 0, y is -3. Like, we could have written that as an ordered pair. These are the ordered pairs. These are solutions to our function. -1, 4, 1, -2. Kind of friendly reminder. So here would be my new function. right? This is the cube root of x minus 3. This graph was shifted down 3. So if you know what the original function looked like, that cube root of x shifted down 3, you didn't necessarily have to solve for the 3-ordered pairs. You could have just shifted every point down 1, 2, 3 to find your new points.